for a good reason, because hardware design is ugly, man. It bites back. Well, introducing myself, I'm Gondo. My actual name is Álvaro, but that's like a Portuguese name which most languages actually can't pronounce. Gondolindrim, which is based off of Tolkien's Elven lore, is a nice one because Gondo is like this set of phonetics that almost every language has. So from the Chinese manufacturers that I work with to the American guys or to
Interesting.
the Europeans, everyone can say Gondo, right? So it's a pretty nice name in that regard. Um, I'm Brazilian. I'm an engineer. I'm an electronics engineer. I've been trifling, doing electronics since the age of 11.
Wow.
Yeah, it's been a long time. I'm 26, and uh, that's pretty much it. I do keyboard stuff. I design keyboards. I design keyboard PCBs are my thing, but I have designed full keyboards before. I come from audio, so I'm a huge audiophile. Designed decks, amps, tube amps, whatever you can imagine. I've done. And professionally, I'm an engineer. I'm an electronics engineer. I have a master's degree and I have a PhD engineer.
Wow. Wow. Impressive,
That's
man.
my.
And so,
I
from
like
what
it.
I've seen online, you've
Like I
been
say.
doing PCB design for like 6 or 7 years as a service at this point. How did you make the transition from audio engineering professionally to doing it for the keyboard industry?
It's weird, man. It started with an uncle of mine. Uncle, I think in English you would call it Uncle Marcus, right? So Uncle Marcus, he was the youngest of my mom's brothers and my mom's siblings, and I was kind of a baby, and he was 14, and he lived with me, my mom, and my dad. He was in high school. Here in Brazil, we have something that the USA does not have, but the Europe does have, which is what we call a professional high school, where people they do high school, but they also learn a profession. I guess in the USA, that's more what you guys would call community colleges. That's more in that gist.
Yeah, it's
It's
like a
not
trade
like the
school. I went to high school in
trade school.
Canada. I went to high school in
Yeah,
Canada, and we had something similar there where you could take college trades courses during high school.
I generally focus for North America, Canada, and US because that's like 90% of the hobby and most people that watch this. But yeah, I think that's what it does. Germany, for instance, they have like 3 or 4 different high schools, and
Mm.
one of them is that. So it varies from country to country. But Uncle Marcus he did a trade school in electronics, so he would do high school in electronics, and it got me at first time, and he was really well into music. When as I grew, we always kept in contact. He was very close to my mom. Not exactly very close. He was a very reserved person. He was very quiet, but he was always very awesome. And that kind of got me into music since freaking always. It doesn't help that my dad also loved music. I had a blast with my dad. My dad he had this 3-in-1 in the 1980s and 90s. It was a very weird time because we had tapes and vinyls and CDs, so we had these 3-in-1 systems that did it all. My dad had one of these, and he had like this it was kind of a wardrobe just for his CD, which that we classical to pop to jazz. So I was always very into that. And as soon as I got a little bit more mature, 11 years old, I started learning the guitar, right, the electric guitar. And I needed to make the effect pedals, right? So an electric guitar sounds
Oh,
pretty much
sure.
like an acoustic one if you don't have any pedals. But if you need that heavy metal sound, you need the distortion. Those are crazy expensive here in Brazil, as in a Boss distortion pedal, which is like what everyone knows. The Metal Zone pedal costs like 500 to 600 reais, Brazilian currency reais. But that's like half the average monthly salary. So
Oh, wow.
uh, yeah, you would need to work half a month to get one of those. It's crazy expensive. So like, yep, f this, right? Let's make our own. So Uncle Marcus was the guy that helped me. He he would drive me into stores and to buy components and get projects from the internet. And he was very awesome. This flag here, this is an Iron Maiden flag.
Awesome.
It shows Eddie, their mascot, as William Wallace, right, the Klansman. It's a pretty rare flag. That's his. And that's what got me into it. I've been designing those things. Of course, first I didn't start designing them, but as time grew, I was just replicating circuits and
Sure.
mixing them up and adding here, adding there. But as soon as that grew, a couple years later, was designing them from scratch. To the point where I had a band, I did have bands, and all my equipment was designed and made by myself.
Awesome.
And that's awesome.
And so then how did you make that transition from that to keyboard PCBs?
That's the thing. When I was in that was a little bit later, right? So when I got into college, I was 18. So second year of college, I think you guys would call that a senior year. I get.
Yeah, I went to high school in Canada, so I'm not sure what the U.S. words are for it.
Yeah, they're the senior, the sophomore. I always get mixed up in the names. But second year of college, we had this electronic engineering. We had this laboratory on microcontrollers, right? At the time, I was playing this Korean game called Mu and You. As we had the clans, right? So those RPGs, MMORPGs, we had clans where we get together and do stuff together, that kind of thing. Being a Korean game, most people were Korean. I had a friend in college who was in like every class with me, and he was Brazilian, but his father, his mom, they were South Korean. So he spoke, and he would help me go doing. I wasn't it for the lols, honestly. I was much more into WoW and Lineage 2 at the time.
Sure.
But he was so awesome that I was playing with him, and that got us into this little forum that at the time was called the OTD forum.
Oh, okay. Yep.
So in 2013, that's when I started being a regular on OTD. Then again, at the time I was 19. I didn't have money to buy anything. Had I had the money, I would be freaking rich right now. Those keyboards on OTD they sell for small fortunes, right? But that was not the case. But I did see the what we call the mechanical keyboard hobby grow from pretty much zero, from pretty much a bunch of neckbeards that modded OEM keyboards to people that started designing their own, right? And at the same time that happened, I had this laboratory course in microcontrollers. Where I like, that's it. I'm gonna make
Perfect.
And I did. So I did. I made a. That was the final project of the course, was to make a simple circuit. I just went all out. I make a fully fledged keyboard using an 8051 microcontroller that was written in assembly. Pretty old architecture. It shouldn't be used in colleges anymore. It is what it is. And at the time, that PCB was called the Hammerhead. Because that was the nickname we gave a friend of ours, because he had eyes that bulged like outwards.
Oh.
But we called him the Hammerhead. That was his nickname. Yeah. So he helped me with like a bunch of code, because assembly is very difficult. It's a very machine-oriented language. I mean, it's machine code. It's literally machine
Right.
things.
Right.
And I gave the name after him, and that's when it began. From then on, I started designing stuff. My first keyboard PCB, serious keyboard PCB, was a variation on the Hammerhead, which used an Arduino. At the time, there was this little keyboard. This was 2014 or 15. That was called the MJ40. The MJ40 was revolutionary in its time because it was the first widely sold 40%, staggered 40%. Ortho
okay.
wasn't a thing back then. I had a friend of mine that had an MJ40 here in Brazil, but the PCB was botched. And I was like, "Yep, I'm making one," and that was my first serious PCB. From there, it just gotten on. I designed a bunch of PCBs by then. I had done lots and lots of PCBs. That was only for the fun of it. I never had intent of it becoming as big as it is right now. In 2018, if I believe, I was watching some YouTube videos, and YouTube recommended me a channel of a guy named Mr. Key, a Brazilian content creator.
Mm-hmm.
I believe he has the largest keyboard collection in the world. Like it's 150 keyboards or something. It's
God,
insane. Yeah, he has like a room in his house just for keyboard stuff. He has wardrobes full of key sets.
Unreal.
It's really heaven, honestly. In Brazil, we have a huge problem, which is getting keyboard parts is very difficult here. We're not a huge market. The Brazilian currency is a very weak currency, so everything that you buy, you need to buy from outside, from the US and China and that kind of stuff, and everything is quoted in dollars. And the dollar to Brazilian currency real, the conversion is always very high, like it's 3-1, 4-1. Last year it got even to 6-1. And when I got into the server, I saw there an opportunity to make these PCBs for the Brazilian guys that wanted them but couldn't get them, right? Mr. Keeps, he actually funded the first PCBs, right? So he paid for the first PCBs, which would later become the Arctic PCB and the Keeps PCB, which are 60% tray mounts. Nothing really special about them, but he started funding it, and the whole Ekron project thing, which is the open source repository of resources, came from his idea. He was like, you do all of this stuff, but you should get it out there, right? Even if it doesn't get you anything money-wise or recognition-wise, you should just get it out there, because you shouldn't work just to keep it clogged up in a wardrobe or in a hard drive somewhere. It just, how can I say this? It just grew and grew, right? Then after that, it came the Shark PCB, which is the worth of 40%. Then the Austin, which is an 800 CP.
Sure.
And yeah, that's. From there, it just grew and grew and grew, and to where I am right now.
That's really interesting that it started within the Brazilian market and grew out from there. That's kind of an incredible story of how those forums can do that, where people from all over the world will get connected through these mutual things they share. We actually connected in the comments of my Mode 65 build video, which you designed Mode's PCBs, with the Sonnet coming up. Very excited about that board as well. Kind of coming from there, I was watching one of your streams for the Mountain Alice, the 1800 Southpaw, or I guess full-size Southpaw, really, coming. And you were pretty far into that one already, so a lot of that was over my head when I was watching that. But I've always been really interested in how that process is. So using something more simple like the 65 from Mode, a company comes to you with an idea. What does that process look like? Does Mode just say, we want a 65, here's the dimensions? What kind of stuff do you need from them? What does that process look like?
It depends on what the. So I work as a contractor. I work as a PCB designer, and that's a contractor. We have an agreement, that kind of thing, payment, all of that is said in there. So it depends on what what the client wants. Sometimes, like the Mount Alice, they will want something that's something that's never been done before. The Mount Alice particularly has the knob, the encoder. The Mode 65 was a little bit different, because what happened was the Mode 65 had something different, which was the microcontroller, right? We started designing the 65 when the microcontroller shortage was just started hitting. And what they did was basically they bought like 5,000 microcontrollers, and they were like, yeah, make a PCB with those. And I was like, what the heck, right? Gladly, we eventually made it work. But that's different from someone that just wants a keyboard. They just want a PCB. So I'll give you an example. Smith & Broom, right? The Iron 180, Iron 165, and Iron 160. Now, I've designed all of those. and they're pretty straightforward. They're awesome PCBs. Their keyboards are awesome. Matt, Luke, amazing people. Uh, and the PCB is pretty simple. They want a PCB that has lighting, RGBs, has their logos. So in that case, it's pretty much just a matter of give me the outlines, as in how farther I can go until it fits inside the case, the layouts that you want, if you want ISO, if you don't. When the process is a little bit more intricate, then more back and forth is needed. As in, I need to filter out what the person wants and understand what the person wants. On the Manalis, for instance, I did actively help on the keyboard design. I did give Board, which is the Manalis designer, some tips on how he should make the keyboard because that's his first board.
Oh wow, I didn't realize that.
Yeah, he's a newcomer pretty much.
It's an ambitious first board.
Yeah. Oh yeah, and it's awesome because I am at this point in my quote unquote keyboard career, if that's a thing, where I can start picking up projects and people that I want to work on, people that I want to work with. And as soon as I saw the Mount Alice, I was like, yeah, I'm all over that. I'm all over that. And I told him that's an amazing board, right? But I had to help him do some things, as in, well, the plate you should do like this and this and this, and they laser cut that, and the case should be designed with this angle, which is the one that most people like. The encoder, it should be at this position here because that frees the hands to use the rest of the keyboard. The Atlas layout itself is a little bit esoteric to work with because of the angled keys, so I had to help him there. So there's a lot of more back and forth that goes into some. From when we have the set of features, from when we have a design PCB, then we go to the prototyping phase. So we go to a fab and give them files, and they give us PCBs. We give them files and money, right? And then they give us PCBs, and then that generally takes 5 to 6 weeks. Just manufacturing the PCB itself. And then we test firmware. We test QMK, we do VIA, we see if the PCB looks good, if it fits inside the case. Generally, the client will build a PCB with the plate to the case and test and see if it does what it is that they wanted. And we iterate from there. Most of the times, just one prototype does the job.
Really? You don't need to do multiple cycles typically?
Yeah, technically speaking, when nothing is new, when no new features are needed, yeah. Unless I screw up something in the design, which can happen, it's called a prototype for a reason, right?
Sure.
But yeah, there was instances where we needed 5 to 6 PCBs, say the Type K, right? The Type K is a keyboard that has 5 iterations of the case, 6 iterations of the PCB, and I think there's gonna be one more because GOC is just a little bit of the back piece. So from the first prototype, we iterate, right? Logos, looks, features. One thing that happens sometimes we add features. So for instance, there was the Evolve PCB, right? The Evolve 75. Which is a keyboard that features a generative bottom, pretty awesome. And the Evolve is quite awesome because the encoder on the Evolve, I have it right here. The encoder, it not only it rotates and it clicks, but it's also a joystick.
Oh, whoa! I did not know that.
And it is pretty awesome. And I invented something called the encoder modes, which are awesome too. But then Nathan, which is the Evolve designer, he was like, yeah, but the problem with the encoder joystick is that it's way too much, right? The idea of the Evolve is being this over-engineering hunk of keyboard, right? That every detail that you look into is just over the top, from the bottom to the layout, to the 75, to the encoder, to the lighting, everything.
There's a lot going on, yeah.
Yeah, and I was well. I know what you mean, and indeed, it is a lot to get to operate the encoder because there are lots of things it can do. But that's the whole thing of the keyboard. Why don't we do a footprint that supports both the normal encoder that just rotates and clicks, and this one that does a joystick? So we are doing a second iteration now that does that. So sometimes in a prototype, not only you iterate on what's there, but sometimes you remove or add features. Uh, um, so it's a very creative process sometimes, or sometimes it's just a run-of-the-mill keyboard PCB.
Yeah, so in terms of what a designer needs to bring to the table, it sounds like it really could be anything from here's the dimensions of my TKL to here's the Mountain Alice. This is my first time doing this. I need help with layout. I need help with options. I need help with case design. It really could be anywhere in between. It sounds like if someone wants to enlist your services for getting a PCB done.
Pretty much. What I do is I like to be involved in the project, right? Then again, I am at the point that I can choose what and who I want to work with. So when I get a project, I get that project because I believe in it, and I think that it's particularly awesome, and I want that to be as awesome as it can be. So lots of times, actually, I would say even like half of the times, the people that approach me for keyboard PCBs, they are newcomers. They are awesome in CAD design. They know their CAD designs. They know SolidWorks. They know Fusion. They know how to design, but they are not into the whole keyboard community thing. They don't know the names. They don't know layouts. They don't know how we do things. The whole CGB mechanic, the streamers thing. So I'm how can I say this? I'm the first professional contact with the community that people have. So sometimes I have to break it down to them as okay. So the way that we do the marketing or the way that we get spread the word out is through an interest check where you get a feedback. A group buy phase is just the final end of the line thing where it starts selling stuff from IC to GP. Lots and lots and lots of time and effort that go into that. I have to explain them how the community works, a little bit of a history of the community. Some people don't understand why there are $5,000 to $6,000 keyboards, and I have to explain to them that there's some history going on about the OTP, about the current thing. Some people don't understand the drama. Recently, as a matter of fact, was it yesterday or the day before yesterday? I spent like an hour and a half explaining some of my clients the whole Holy Panda thing. Right?
Oh.
So I got from like the first Halo IC versus mass drop drama thing to the Holy Drop Panda X.
Yep.
So there was a lot to explain and why the Holy Panda is just such a huge thing in the community, and I would like to think that being a very seasoned member gives me some authority to approach those topics, right?
Yeah, there's very little what I would call institutional knowledge about keyboards. It's all in the community. It's all in forums. It's all in poorly maintained wikis here and there, on different websites. It's experience says a lot in this community for certain in terms of what you are capable of knowing, and like having the ability to explain something like the Holy Panda timeline to someone is like that is a very unique set of knowledge to have. Theremin Goat's article about it is a little out of date now with the Holy Panda X's being out. And certainly if you were in the forums at the time, you probably saw parts that aren't documented anywhere else, because it was a whole community discussion. It was a community designed switch.
And I know a lot of the backstage too, because
that's a great way of putting it.
Being how can I say this? The thing is, the community as it was built by DIYers. That's what people generally forget. Our community a couple of years ago was built by people that were willing to design their own stuff and put it out. That's what IC is. The IC thing was born as someone that made, hey, listen, I made this cool thing and I want to make it. If we get it in lots, we can make it cheaper. So why not pitch it to people to see if anyone is interested, right? Lots of boards were born that way.
Yeah.
The Austin, which is the 800 CP, was born that way. Drifting Bunnies, which is the owner, he's an accountant, and he need his goddamn
Oh,
numpad,
interesting.
right? And he was like, yeah, I need this keyboard, but it's too expensive, and if we do a 20, 30 unit run, maybe we can bring it back. So he just wanted a unit for himself. He was willing to put in some elbow grease to make it happen. And it was it was a good success. It did sell well. It got into R3
Yeah.
just right now. So yeah, that's how the IC became, right? And knowing how that ICGB mechanic culture thing came on helps you understand that the community was built on people that were willing to do that. As on the other hand, the newer guys that come in, people that are coming in, are generally people that are not really seasoned with DIY, not really seasoned soldering stuff, not really seasoning with design. They just want nice keyboards. That's totally valid. You don't need a PhD in engineering to make a keyboard. As a matter of fact, as far as I know, me and Heinebusch, we are the only engineers, electronic engineers
Interesting.
in the community. All the other big guys are pretty much, all everywhere. AI, Wilba, Olivia, they are computer scientists. Mac Merlin, UPAs, I believe they're not even high. I'm trying to remember. I think that, if I remember correctly, Merlin has higher training, but it's not even in technical area. He's like from humanities or something.
Oh, okay.
It's a very nice thing where the community coexists in those two sides of some people that are the hard and true keyboard enthusiasts that are willing to design and solder, and the people that just want nice stuff. They want nice keyboards and they want it at an affordable price and all of that. And those two sides, they join very well together. And we are starting to. The thing is, the community doesn't have like an institutional archive or museum or forum because the community was built that way. The community was built by DIYers. The community, much differently from, say, the audio or the mouse communities, which are represented by big companies, right? So the headphones I'm wearing right now, those are Bayer Dynamics, right? If you go to the Bayer Dynamic webpage, which is a multi-million company, you would expect a nicely laid webpage. You would expect a history. You would expect a support. You would expect that was not a thing. That was never a thing. We only have companies doing things in this community. You only started seeing that a couple of years ago from now, right? So that's why all of the knowledge is scattered around. That's why, and I think that that's a good thing. I think that that's a thing that separates us from all of the other communities in that regard, hobby communities. In that, a lot the community factor is a lot more important in that sense. I'm an audiophile. I have very expensive audio equipment. I design audio equipment myself, but I'm not really a part of that community. It's not my thing. I never found an entrance where I was comfortable getting in. I just like music. I just like playing, composing, and designing electronics. And I can be a part of the community, not exactly being a regular member in forums and that thing. Keyboard-wise, not a thing. In the keyboard community, if you want to get the full experience of the community, you need to get involved.
Yeah.
You need to get into forums. You need to get into Reddit. And you need to get into Geekhack and know what's going on. And there's a lot that's not there. You need to go around, and I like it. I quite like it. I quite love it, honestly.
Since you started designing PCBs for keyboards, what do you feel like has changed the most in the expectations people have of the PCBs? You mentioned early on it was hobbyists who were comfortable with soldering, so obviously like you look at something like the Icky 68 PCB, that thing's covered in hot swap sockets to give you as many options as possible. But as a designer, like do companies come to you with like higher expectations in certain places? Like what's different now?
The thing is, when I arrived in the community, this was when I arrived as a designer, as someone that was publicly saying I am a designer, because even though I was in this community as a regular member, going to forums and discussing with people since 2014, I was not a guy that was out there saying I design stuff from 2018, 19, right? So ever since I gotten into that, when I got into the community, I was already very well seasoned with high-end consumer electronics design. So lots of the things, for instance, I am very proud to say I was pretty much, if not one of, or the first guy to implement certain protection features on keyboards, as in electrostatic discharge, overload over current,
Oh, really?
electromagnetic interference. I was the first guy, and I started pushing it. The thing is, when I got into the community, some months after I got into the community, we had problems. For instance, I had a friend of mine that had the plank PCB, and his plank PCB was fried the heck out of. Didn't have ESD protection, and electrical installations in general, they are not known to be very safe. Even though we would like them, they are not. Uh, in fact, as an engineer, sometimes you wonder how the heck does it work so well when it's just so badly supervised. But that's another 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 issue. But we also had the same problem with the Rama U80. I think it was the first round of the U80 where the keyboards would literally shock you. They would literally get you some pricks. I think that's a good word. They would give you some slight shock.
Just like a little prick, a little like
Pricks.
electrical discharge. Yep.
I think that's a good word, a prick. And some people would reset, some people would fry the microcontrollers, and I was like, yeah, they don't have any protection. So when I started designing stuff, I started implementing those kinds of protections, and soon they followed. For instance, today everyone uses the universal daughter board, the C3 universal daughter board. I designed it. I designed the C3
Oh, no
universal
way.
daughter board with integrated ESD and EMI based on AI's C1.
Okay.
So I took AI C1, charged in with ESD and other stuff, fuse and over voltage and over current, and now everyone uses that. So that's one of the things. These days, however, it's pretty much a given. These days, when we go talk to someone, uh, it's not even on the table. It's just a given that the PC has all of those protection features. Even though some people have no idea what they are, they do know their acronyms. They do know what they need. You know that the community wants them, right? And that's also a big portion of my job, is to explain to makers and designers what the heck certain things mean, right? As in, what's ESD? Where does ESD come from? Where does EMI come from? What's over voltage? What's overload? How does that impact my design? How do you deal with that? And that kind of thing. Recently, I was having trouble with Geons. I'm designing Geons Frog Mini and the Vanquish 65 PCBs. And the Vanquish 65 has a totally new mounting style, right? And his mounting style is based on little aluminum posts that go into the PCB. He calls it tray mounts. And those aluminum posts are conductive. That affects ESD and EMI, so I spent quite a lot of time explaining to him why it is that I'm designing the PCB as it is right now, and why certain spots have metallized plating, why other spots do not, and that kind of thing. So today, technically speaking, the community is a lot more. How can I say this? More. Their standards are much higher. I would say, I think a good word is they're much more demanding of designers. Designers
Okay.
need to be, the designing level just got up to a whole new. What you expect, you expect a lot more from designers. You expect designers to comply to certain features that a couple years ago were just right. Um, the community has also changed on how it reacts, how designers are involved in the community. We are in a very weird spot right now, where a $1 million company, a multi-million-dollar company like Job, can coexist with smaller companies like Novelkeys and Canokeys and Omnitype. And DIY designers such as me, I do a very different thing, which is the whole open source thing. but there's also Wilba and AI and Heine, which are people that do very uh, um, stuff that's more exclusive and artistic rather than aimed at lots of people, right? Of course, we are seeing, for instance, novel keys and Canon keys doing, let's say, the Becanicos, the NK65s, NK80s, which are aimed at a larger audience. That's awesome. But that wasn't the thing, right? It is expected of the community to deliver a lot more than it was able to. And I say this because designers in the community romanticize that time of the community when it was much more artistic. It was much more artistry focused, right? So, for instance, I have this keyboard here is the Andromeda, right? An awesome T-keyless by AI. Awesome color. I got the rose gold. It's amazing.
Beautiful. Yeah.
I'm mesmerized by the whole keyboard. And you get the keyboard on your hands, and I can say that about a lot of keyboards. I have Geons F1s, I have two F1s, I have Satisfaction 75, I have the 7V. They're amazing keyboards that you look at and you see expression there. You see art in its purest form it's an expression of an artist, someone that made this, and you can see personality there. You can see that no one could make the keyboard but that person. And that's awesome. That's amazing, right? But that's not something that you can support on a large scale. That's very difficult to support on a large scale, right? That kind of mentality has to coexist with a mentality of people that want a nice keyboard that does its job, right? I'm not saying that one is good or one is bad. I mean, I'm using an NK65 here, an
right
edition. An awesome little keyboard, might I add. It's amazing. It's been my daily driver for like the past week.
I just got the new milkshake keys in yesterday and built my thermal for the first time.
Amazing. Nice.
The milkshake colors are so fun.
They're amazing. Yeah, they're very pretty. And we are adjusting to that, right? Myself, I was always very customer focused, right? I was always that guy that says, listen, the ultimate word is from whoever's going to use this. So my PCBs, they have adapted very well to that new thing where people needed something that could do a lot more. So yeah, that kind of different mentality in how the community grew, it did demand a lot more from designers.
And so that feels like a really good lead into the second main topic I wanted to hit, which is the Joker architecture. I had never heard about this till that Mountain Alice stream I watched, and I'm going to explain what I think it is, then I want you to tell me why I'm wrong. My understanding was the Joker architecture is a footprint on the PCB that supports multiple different microcontrollers as a result of the global chip shortage that's occurring right now. Is that accurate? How does that work? I want to hear all about that. I am so curious about how that is.
That's a good introduction. Yes. Well, today is April 10th, 2022. We're going through a very rough semiconductor shortage. The reasons for that are multiple. I have an article up with some references for people that want to read a little bit more on that. Let me get you the link. I'm going to get you the link on that right now.
Perfect. I'll make sure that's included in the video description too.
There we go. So, the thing is, the keyboard community grew because the backbone of the keyboard community today is QMK. We have other firmwares coming in, like ZMK, for instance, but QMK is still the to-go. QMK was born from a guy named Hasu. The project was named the TMK, right? Hasu made the TMK for the Teensy. The Teensy is a little feather board.
Oh, yeah.
Based on the Mega architecture. The QMK is actually a fork of TMK by Jack Humbert, the OLKB owner, designer of the plank. and it's open source, and it grew to the way that it is right now. And the problem with the AVR platform, that Mega microcontroller, is it's a weak microcontroller. It's not a good microcontroller in the sense that it was not made for consumer electronics. It's a very old platform. It doesn't do the job very well. But the keyboard community got into a point where it needed more uh, higher end peripherals and higher end features, your RGBs, your OLEDs, your first of all, what do I mean by it's not a good microcontroller? You can do lots of things with the AVR platform. But the problem is that it simply does not have the throughput to do certain things. For instance, per key RGB. There is a way to do per key RGB, which is using 2812 LEDs, and that means that for every LEDs, every color is basically a 24-bit string. And when you tell the microcontroller, listen, I want the LED to be this particular color, it's basically the microcontroller sends that LED in 24-bit string. When I mean a 24-bit, I mean a sequence of 24 ones and zeros, and that defines a color, right? Okay. The problem is that in a keyboard, you have lots of LEDs. And let's round it out to 100. In a 10 kilos, for instance, you have 90, 87, 88. So every time you want to update the per key RGB lighting, a microcontroller has to calculate, rounding to 100 LEDs, a 2400-bit huge string and send it out to microcontrollers. The AVR family of microcontrollers cannot do that. It stalls. So the animations on a keyboard, so right now I'm using this keyboard here and it has an animation, right? So the colors cycle around. Mm-hmm. You can visibly see the colors freezing and the keyboard is a little bit slower to type on because the microcontroller is just focused on doing
really
the per key thing. Yeah.
And so when you say the AVR, those are the ATmega chips
that we
commonly see. Okay.
Other problems with the 8 megas are their low memory size. So there are people that, for instance, need to remove layers on their keyboards to make those, to make the firmware get inside there. VIA is also a little bit of a problem because VIA introduces the need for persistent memory rather. So all of those features, when you try to cram them in the same microcontroller, it demands a lot of microcontrollers. So it got to a point where we needed good microcontrollers, and that's where the STM32 family comes in. The STM32 family of microcontrollers is a very mature, very good line and family of microcontrollers. And the QMK guys made that work with an operating system. It's literally an operating system called Chibi operating system, GUS. That does the job. That does the job pretty well. The nice thing about the STM is that the STM line of microcontrollers, it has a family. It has lots of families, as a matter of fact. It has the F1, the F2, the F3, 4s, 5, 7, and something like that. And each family is aimed at a particular market share, right? So, for instance, the F4s, they're marketed for people that need real-time signal processing. The F0s are aimed at cheap consumer electronics. The F1s, they are very, very old. They are made for prototyping and making the code. The F3s, they are aimed for analog signal processing. They have bit depth, very high bit depth, and very high sampling rates for ADCs and that kind of thing. So what happened when we started doing our microcontrollers, we went for the specialized family, which was F0. F0, especially one of them, which is STM32F072, is a microcontroller that is aimed at being cheap, having connectivity, and doing basic stuff. Keyboards, they are not the pinnacle of human technology. They're pretty simple. You don't need a huge microcontroller. You don't need an i5 to run a keyboard. You need a good microcontroller, right? And we started doing that. The problem with that is that you rely on a single part to make your system is as secure as that single part, and that's pretty much what happened. Once the semiconductor shortage hit, we started having trouble sourcing those. It's hard to explain to people how deep and overwhelming this shortage is. We are going to see consequences of this shortage for decades to go. For instance, countries, what basically happened in a very, very, very mild explanation is the whole world stopped. But there was a country in particular, China, basically because it was the epicenter of the whole thing. The problem is that China is the largest semiconductor manufacturer in the world. All of the big manufacturers are there. Once those guys simply stopped doing what the factory's thing, the whole logistics chain came down. So now countries, they are seeking ways, now that they know that they cannot rely on a single country to do all of that, because it's a very strategic market, they're starting to do foundries and manufacturers in their own territory. In the US, Intel and AMD, they're spending billions, tens of billions into manufacturing semiconductors in the US. In Europe too, TSMC. We have some initiatives here in Brazil, but they're not going forward anyways. So the impacts on economy, the impacts on politics, the semiconductor industry at the higher end is something that's treated as, it's not even trade secrets, it's like state secrets, right? Because among other things, military ends, right? So a lot of the higher end microcontrollers and semiconductors, they're not even available to end consumers. They're limited to certain military uses. For instance, the GPS, there are laws in the US that limit how powerful, in a very broad sense, the cell phone GPSs are, because you can literally make ballistic missiles with those. You can use your cell phones to make weapons because of the GPS. You can track stuff with your GPS. So that kind of technology can start wars around. It's very important. It's very strategic for states. It's very hard to explain how deep that goes into politics, into society, but rather I will try to explain how that affects us in the community, right? STM32F072 CBT6 or C8T6, which are the same microcontroller with 64 128 kilobits memory, were microcontrollers that I used to buy for $2 a piece, 180 to 10, something like that. These days, they are not even available anymore. They haven't been for a year. When they are available, they sell for $30.
No way.
I can't make a keyboard out of that. I can't sell a PCB out of that. People, they're not willing to pay $90 on a PCB because the microcontroller costs that. So what I did was I basically designed a circuit that allows us to use multiple STM32 microcontrollers. The STM32 microcontroller family is aimed at portability. It is aimed at you being able to replace microcontrollers in and out depending on your needs, applications, right? It's a very nice feature of them. The problem being that each microcontroller has a particular way of doing things. For instance, the STM32F072 in QMK, it doesn't have a peripheral that we call a timer. Well, a microcontroller needs to count time, right? It's a very useful feature for lots of things. One of those being controlling pulses. So for a wide variety of applications, you basically want your pen to go from 0 to 5 and stay on 5 for a certain amount of time and go down. STM32, it has very bad, the timers on F072 are not good, they are not high resolution. So instead, to do, for instance, RGB, we use a peripheral called SPI, 0 serial peripheral integration of SPI communication. I forget what the acronym stands for. It's serial peripheral interface. The problem is that STM32F4 does have a timer, and a good one at that. To the point where 32F072 does RGB much worse than F4, because the timer peripheral of F4 has something that we call DMA, or direct memory access, which means that the timer peripheral that controls RGB, it can access memory directly instead of asking the microcontroller all the time to throughput the code or the pulses for whatever it is that it.
So when you say it does RGB better, what would a customer notice with the worst one? Like, would the animations not be as smooth? What would the problem be?
Exactly. The animations would not be as smooth.
Got it.
Other problems is F072 does not have enough flash to go VIA. Now, VIA, what is VIA? The idea of VIA is what we call persistent memory. So let me explain. Memory is an umbrella term for a device that stores information. The problem is that there's a cornucopia of different ways a device can store information. So let's take your computer. So if you take a computer, I'm saying a desktop. You have different memories. You have your SSD, you have your hard drive. SSD and hard drive are the same thing, but let's take you have a hard drive, you have a RAM memory, and you have your cache memory, and you have your video memory. You have these 4 types of memory. What do they entail? Well, RAM memory, it's very fast, right? It stores a lot of things in a fast way, and it has random access. So the fact that it has random access means that it has something that we call ECC, or error correction code. It's very important for servers. The problem being that it's not that fast. And it's not persistent. As soon as you turn it off, it loses all of the information. The cache memory that's inside the microcontroller is lightning fast, but it's way too expensive. Hence why you have just a couple megabytes in your microcontroller. The hard drive is a memory that's not really fast, but it's cheap. You can get lots and lots and lots of gigabytes for a nice cheap price. So video memory is something that is fast, it does its thing, but it's optimized at doing calculations, at storing numbers. A GPU is basically a very fast calculator. A microcontroller, as we use in keyboards, it also has different types of memory. The problem is that a keyboard microcontroller, it has something that we call the firmware. Your computer has a firmware too. That's what we call the BIOS. It needs some basic low-level code to minimally operate your microprocessor in your computer. That's not different with microcontrollers. They need the firmware. That's QMK. QMK basically operates in low level in these microcontrollers. Okay. The flash memory, which is where all of that program is stored, it can't be changed during runtime. Why? Because you can't change the program during runtime. That's a huge security problem and reliability problem. The problem is that doesn't play well with VIA now, does it? You want to be able to change your layout without needing to flash again your keyboard. As a matter of fact, we did that back then. A couple of years ago, we were flashing our keyboards all the time testing new firmware. So you want a different type of memory that is not only persistent, but it can also be electrically rewritable.
Okay, sure.
So there is this different type of memory that we call EEPROM, or electrically erasable PROM. And EEPROM is exactly that. It's a persistent memory that can be electrically erased.
Oh, okay, sure.
So that's VIA. That's perfect for VIA because you want to change your layout and you want to be persistent. You don't want to turn your computer off and when you turn it back on, you need to load your layout again. No, you need it to stay the heck where it was. The problem here is that EEPROM is not integrated into microcontrollers. As a matter of fact, there are a couple that do integrate EEPROM. STM32 L052 and L032, I guess, have integrated EEPROM. And the new WB Bluetooth microcontrollers also have integrated EEPROM. As far as I'm aware, some of the F7 also do, something like that. Not all of them, though. So what QMK does in F072 is not only you have the flash memory that stores the microcontroller program, the firmware, but it takes a portion of the flash and it emulates EEPROM. It has its own set of problems. It has its own set of challenges. The main one being flash memory was not made to be erased back and again. So with that emulation, you have to do something that's called wear leveling. I don't want to get into that. The problem is, in F4, that's not available in QMK yet. So you need the EEPROM there. Another thing, some microcontrollers, like STM32F3s, they need some components on the USB lines. They don't integrate certain components in their USB pins to make it fully work. You need a couple of components there. Namely, a pull-up resistor on the D plus line of 1.5K, pulling up to 3.3 volts. Okay. So, how do you make it so that your design supports all of those guys, and at the same time, all of those guys support the features that you need? Because then again, the same feature, like I said, RGB, it's done differently by different microcontrollers. That's the Joker topology.
Okay, so my understanding was you wanted multiple chips based on what was available at the time, was what I gathered. But actually, you have different chips, so you can enable different feature sets without fundamentally changing the footprint on the PCB.
Exactly.
Wow.
So the idea is
That's
exactly
awesome.
as you say. The idea is exactly as you say. During this whole shortage thing, I want to be able to just use any microcontroller available, or a big set of them. It doesn't need to be any, just a good set of them that I can find. But without locking myself to a single one. Because if I depend on that single one, my design is not reliable.
Yeah, you had a single point of failure all of a sudden. Totally.
That's the Joker topology. So it's not... The way that you put it is very accurate. Yeah, it's an idea, it's a footprint that allows me to use a variety of microcontrollers without changing the design. The same design can support various. Under the hood, and when you read a little bit more into it, it's more complicated than that. We are doing drivers, we are talking about low-level coding, we are talking about specifics. I had to read from 10 to 15 different 1,000-page reference manuals to build it.
Oh my god, man.
That's how long reference manuals on these microcontrollers are. The literature is immense. Needless to say, I grew immensely as a designer and as an engineer, but I wasn't. I did need to learn a lot. Let me give you an example. Give me 5. I'll take a couple of PCBs.
Okay, cool.
Here I have with me 2 Iron 165 Revision 2 PCBs.
Right on.
The thing is, each one of them uses a different microcontroller.
Really?
Yes. So what happened was, when Smith and Maroon, me, Matt, and Luke designed Iron 180, there were very many STM32 F072s around that we were able to make 180. So when we started making 165, they still had a good stash of those, but not quite enough to fulfill all of the 165 run. So I said, well, listen, what we can do is let's use the... I first tested the topology in 165 Revision 2. And I told them, listen, why don't we use that topology and you make, say, You spend all of this stash you have on one microcontroller, and then you buy another one to fulfill the rest. That's exactly what it was made. So, this is F072. Now, as you can see, F072, it has the microcontroller here, but you're going to see that there is a component here that's not soldered.
Oh, sure. Yep. I see the empty pads there.
Yep, that's the EEPROM. Because F072 is able to emulate the EEPROM.
Interesting.
You will also see that it also lacks a crystal, because it has a solid state oscillator that's able to do, we call it crystalless USB communication. Okay. It's able to do USB without crystal. What else? And it does RGB. Now, the way it does RGB is through SPI, because it doesn't have the timer peripheral to do this. This version, however, you can see all the wires. This version here has F411.
Okay, so I can see the EEPROM chip to the left there. Yep.
EEPROM is here. Crystal is here.
So to a user, the idea is they would never notice a difference between these two keyboards.
Not a single one.
Fascinating.
It serves the same keyboard. It does the same thing. Firmwares are different. The binaries are different because they're different microcontrollers. But other than that, same keyboard.
Interesting. So it does serve to do both things. It serves to alleviate the chip shortage issues and to allow different feature sets on the same PCB footprint without drastic changes.
That's the thing. They allow the same feature sets. That was a challenge. Different microcontrollers, they do different things different. They do the same thing differently. Those two PCBs have RGB. Underglow. The problem being, F072 uses an SPI driver, and F411 uses a timer driver. A PWM driver, as we call it. How does that work? Right? Well, that's one of the motives of the topology. Even though they use completely different ways to do things, to the user, it's transparent. The functionality is the same.
Yeah.
There is a problem of price. So, for instance, I'm designing 5 PCBs for Xeon, more than that, 6. Also, Noxery, right? I designed 5 PCBs for Zonnet. Yeah, that's what it was. And between Xeon and Zondet, they bought 20,000 microcontrollers.
Holy.
Stock. Why? Because there was a huge stock that came in for $3.80 a piece. Remember, we were buying those at $12, $15, $30 a piece. But suddenly, this huge stock of $3.80 comes. They just ate all of it.
Wow.
Between mode boards, between Zondet, Xeon, just and Iron 165 and 80, my products alone ate up 40. My count is 40,000 microcontrollers.
Wow.
That's the extent of the shortage that we have right now.
That's unbelievable.
And without the Joker topology, all of those would not be possible.
Oh, so the Mode 65, does that have the Joker footprint on it?
I'm not saying 65. I'm saying the 80V2 was on it.
Interesting.
The 65 was just the first approach to F401 or CT6.
Oh, that's where they bought all the chips ahead of time. That's what you're saying, right?
Exactly.
Okay.
Because at the time that they bought it, QMK was first starting to implement support in those, and then we got it working. But it doesn't have the Joker yet.
But the 80V2 and the Sonnet do. Interesting.
The 80V2, the Sonnet do. Yeah.
Wow. I'll have to go back and rewatch my my 80V2 video now. Go back and look at the PCB.
Oh yeah, you probably are.
Yeah, cool.
Does the V2 have it? I can't remember it now. I know for a fact that Sonnet has, because I just delivered some PCB files to them like yesterday or something.
Sure.
I can't remember for the 882, but yeah, something like that.
Yeah.
So the shortage it's that problematic, right? Without the Joker topology, all of those keyboards all of those PCBs would not be possible.
And so you had mentioned open source earlier. Is the Joker topology something anyone can use? Is it something specific to your services? What does that look like?
No, the Joker topology is open source. You can use it right now if you want. As a matter of fact, if you want to use it, the article that I sent you explains how the topology works. It's still under construction. As of right now, I've identified 16 different microcontrollers it should be compatible with.
Whoa.
But there are more that I need to check compatibility on to see if it is or not compatible. But there are ready-to-use KiCad files that you can just copy over and start banking.
That's amazing. I'll make sure to include that article in the description. I'm excited to read that as well.
It's everything very technical. The thing is, it's hard to get to that level of development without getting minimally technical. And but yeah, any person interested can reach me out and ask things.
Yeah, and I hope our conversation here, talking about it in more plain words, is helpful to people understanding it. And to your point, if anyone has questions, you stream all the time, and you answer questions in the chat constantly. So if people want to learn more about this, I would definitely recommend watching your streams and seeing how all this actually works.
Yeah, I think that a big problem of consumer electronics is that all of the design work is hidden. And for a good reason, because hardware design is ugly, man. It bites back. It's very frustrating. Our prototyping round, Apollo 87, which is one of the hot-swap PCBs that Gion that I'm selling, that it developed with Gion. Between the two revisions, we spent like $1,300 in prototyping. What if those prototypes don't work? They did eventually, but what if they didn't? What if I had spent $13,000 and I had to order new prototypes? That's very much a possibility, right? I mean, they're prototypes. But it's very frustrating, and every prototype round takes months because it's a month to design and 2 more months for the fab, and then you have the shipping, and then you have the testing, and it's very frustrating. So when I stream, I aim for two things. First, to get people into designing. I don't want people to be serious about design. I don't want people to venerate me as a huge. No, I want people to see what goes in their keyboards, what goes in what I'm doing here, and the amount of detail and things and education and time that goes into building those things. The other thing that I want is, well, connection, right? I mean, for me, it doesn't make sense if it's not about the community, right? My opinion on the keyboard community is it's not about keyboards, it's about people. Keyboards are just an excuse you use to get together, but in the end, it's about people. And I was always very, very, impressed by how huge keyboard designers, they are accessible through very easy means, actually, like Discord or something like that. So the idea is to open a window for accessibility so that I'm accessible to people. Answer questions, help people design. Some people actually get into designing. Some people in the streams actually get into designing their own stuff. Lots of projects have sprung up that way, so yeah, that's the idea of streaming. I'm more than happy to get people streaming my streams and talking and having a good time. They're not fun. Designing streams, they are very technical. They are a little bothersome sometimes. But it's fun. It's fun. Have a nice time.
Yeah, it's a good time to hang out in those, or listening to good music, answering questions, and chatting. It's a good time. If anyone watching this video has more questions for Gondo, I'll leave his stream link in the description along with the article and his contact form. And Yeah, man. Thanks for reaching out. This was an absolute blast. The Joker architecture, since you talked about it on that stream, I was like, I've been wanting to know more. So this is fantastic.
There's a lot of work to be done still. I want to polish it up a little bit. Right now, it's a little bit rough. It works, has worked for a lot of PCB, but there's still some work to be done, and I would like for it to be. The idea is that people use it, right? I open sourced it for a reason, right? So people start using it, but start getting people into start designing. So if people feel like spending some neurons into electronics and keyboard design, it's very rewarding. It's very nice and very educative too. You learn a lot of it. Absolutely, reach me out. I don't stream regularly. I am a very busy person. Then again, I am a PhD student. I do have a day job, which is I'm a researcher.
Oh, wow.
And the keyboard stuff I generally do at nights and weekends.
Sure. Sure. Well, at least here in Pacific time, you usually pop up on my Twitch at a pretty good time to watch. So
yeah,
keep those notifications on.
I don't stream like regularly. I don't have a time to stream. I just pop it up and start doing it,
sure.
I guess.
Well, I really appreciate you making time
yeah.
to talk today, and I hope this video is watched by many people and that you keep at it. I'm going to keep an eye on the Joker architecture stuff. I'm excited to get my Sonnet PCB now and really take a look at that in person and see what it looks like.
Sonnet PCB is going to be quite awesome, and we are at the final stages. I think that the PCB itself is done. We are just finishing the FR4 plates.
Awesome. Oh yeah, I noticed in the 65 video that your logo is also on the FR4 plate, so I assumed because the circuit board's FR4 and the plate's FR4 that a lot of crossover.
I designed it all. Yeah, I designed the plates and both plates. How many plates does the 65 have?
Oh god, there's like 7 materials.
Plates.
I think there was a lot of them.
No, there are different like formats. I think that there's a hot swap, an NC, an ISO, and like a universal, and then there is a half plate.
Yep. That's correct.
So there are like 4 different plates or something. Sonnet has less than those. It has like a universal and a half plate or something like that.
I think that's what the configurator shows. Yep.
Yeah, I can't remember right now. But yeah, I designed all of them.
Very cool.
So it has my logo and their logo.
Very cool. Well, I'll have a video on that down the road whenever I get my hands on mine. So more to come there.
Awesome.
Awesome. Gondo, thank you so much. I'll have all the links down in the description for people to check out, and I'll see you in the next video.
Hey, this is awesome. Yeah.
Thanks, Gondo.
My dude.